First of all, thanks to Microsoft and Ayeshay and his wonderful team to organize this. I'm really excited. Myself, Santo from Juniper Networks. I worked in a routing protocol team for about 10 years, and then I moved to a management role, managed EVPN and L2 multicast for about 2 years. For the last 8 months, my role is like a product manager. I moved from a software background to a product manager, and in this role, I have to know a lot of hardware stuff. This intro is relevant to my topic, that's why I have detailed it. My topic here is enabling sustainable networking. I want to tell like a story, like why the sustainable networking is a important matter, and how we are going to do something which helps on sustainable networking. And there are some innovations we have done and the community has done it. And finally, I'll go to the call to action. Okay. Networking is all about faster speeds, throughput, latency, right? People are asking the first question, how fast you can move the data from one end to the other end? I would like to change the question into how efficiently you can move the data from one end to other end. That is the networking future. So why the efficiency is important along with performance, let's see that. Okay. We all know what's happening in Kashmir, Leh, Ladakh, Delhi for the last 1 or 2 weeks. The climate change is something is not tomorrow's problem, it's today's problem. We are actually facing it. Our own industry is contributing to the climate change. The ICT networking department, our group, right? We are contributing nearly 3% of global emissions, and the power-hungry data networks, data centers, is taking 6% of global electricity according to the latest. It has 2 to 3, but actually the recent data says the data center consuming 6% of global electricity. So that means we need more power generation, and the transmission networks. It emits more global greenhouse gases, and then it adds more carbon footprint, right? So we want to reduce the carbon footprint and global emissions from our capacity. We are from networking background, right? How can we help to do those two things, right? That's my topic today. We have to focus on energy efficient infrastructure, and the design itself we need to focus. When you design a system, like there are a lot of startups joining this group, right? When they design the system, they have to think sustainability on day 1 and day 2 itself. When you design a network topology, you need to have a thought of sustainability. Here, when I say sustainability, I want to focus more on the power consumption, reducing the power consumption, right? That's my focus. Let's see why this is important and what we have done it. Okay. Few years back, we asked a tier 1 customer from USA to give me your day-to-day traffic. They have shared with us. This is the traffic flow. As you see, right, traffic is dynamic. Every hour it varies, every day it varies, and every season it varies. This is the traffic flow in a day, right? Let's see the power consumption in this network. You see the straight line, power consumption is not varying. It's very inefficient system. The system is not forwarding any traffic, but the power consumption of the system is same, which is very odd. So we have put a lot of power optimization techniques in the system as well as in the whole network, and then we have done this. We made the power consumption also follows the traffic pattern. With this, like, we reduce a lot of waste, and then we save the energy bill for the customer. Customer is happy for that. This is from tier 1 USA customer. We did similar implementation, similar project in our tier 1 European network. We found we have up to 85% of waste. By putting all the power optimization technique, whatever we have known, we have done so far in their network, we could achieve 55% of power savings. These are all the data point and the real experiments done on the real customer topology. Let's see what are the things we have done and how we can replicate these things to the whole world, whole customers, so we can reduce our power consumption in the networks. That intends help the sustainability. Okay, before I talk more on reducing the power consumption or optimizing the power, right? I want to talk about the measurement and monitoring, because if you want to optimize something, you should be able to measure it first. If you cannot measure it, you cannot optimize it, right? So I want to talk about the measurement and monitoring. Let's take one of our networking system. So in our system, there are few components which consumes power. We need to monitor all those things regularly. I would like to tell few parameters which consumes power in our hardware. Ports, MACsec, if you don't want MACsec, you can switch off it so that we save some power. PFE, A6, of course, A6 is a giant in the system. PSU, power supply redundancy, and optics. Optics, it's very weird for me, like when I move from software to this role. The total power consumption of optics is more than the system. It's very weird for me. And then the CPU usage and the ambient temperature. When the temperature is more, the power consumption of the box is more, because we need to speed up the fan and do a lot of things, so the power consumption goes high. Elevation, it's also a new thing for me. Same box, same configuration, same port, same optics. You put it in Bangalore, it will give some power consumption number. You put it in Amsterdam, it will give different power consumption. So the elevation is really matters. So these are the parameters which consumes the power in our hardware. Not just the hardware parameters, I would like to mention few things from the traffic point of view. When the congestion is more, we consume more power, we can test it that. Packet size, it depends on the packet size in the network. That also affects the power consumption. Payload, traffic mesh, throughput, so these are the factors which affect the power consumption of a system, right? So we need a real telemetry to collect all these things and monitor it, and then so that it will help optimizing the specific component of this system, right? So once you know which thing is taking more power, so you can able to think how to optimize it. So that's the reason we go in detail and see what are the parameters are taking more power. That's about power measurement and monitoring. Got it. So now I move into the power optimization area. We have done power optimization in many levels. First, we have done it at system level, what we can do in our system, and then we replicate that into the network level, and then the protocol level, the routing protocol level, what are the things we could do to improve reduce the power consumption, right? In the system level, this is a high level hardware overview diagram of any system across vendors. You can assume the PFE here is ASIC. We will have multiple SerDes connected to each and every port. On the port, we used to have the optics, right? In our system, natively, if the port is empty, we shut down the SerDes, so we save some power. If it's, it depends, sometimes 8 SerDes lane connects to port 0, or 4 SerDes may connect to one port. It's based upon the design. So in this slide, the port 3, we have customer has connected the optics, but actually they are not using it. That means the SerDes is on, so we are wasting some power over there. So we requested them to mark the port as unused. There is a config. So with that, we could able to shut down the SerDes. So that saves some power. This is one simple example, right? When you are not using the ports, just go and mark it as unused, so it saves some power. More at system level, I think many vendors have a system with have multiple ASIC inside that. Our company system is like this. We have 3 ASICs, a couple of PHYs and ports, right? Let's say some customers bought this system and then have one port connected in the top, one port connected in the bottom, not remaining are empty. By the way, only the data center customers use all the ports, not the enterprise or not the service provider customers. They do buy it for just for 5 ports or 2 ports. We do have the scenarios, right? So in those cases, we can do a lot of things. Let's say they are using only 2 ports, which is connected to the top ASIC. We can power off these the last 2 ASIC. We have the flexibility, and whenever they connect a new port or when the traffic comes, right, we can power on the PC. So we should have the flexibility of powering off and on of all those ASICs, right? That is one thing, and we could intelligently move the ports to the topmost PFE, right? We can rearrange the ports so that you can see whether is there an opportunity to power off the PFE, right? We could apply those thinkings. This is at PFE level. So we powered off one ASIC. See how much power we are saving here. Around 170 watts we save here. We powered off one more PFE, so we saved around 140. So totally by switching off 2 ASICs, we saved around 300 watts of power in a single unit, right? That's the reason I was asking when Chintan was presenting, like how much power this particular ASIC is consuming, right? Suppose future if someone is designing a system with multiple ASICs, we need to know like how much it saves. Okay, there are more things to optimize it in the system level. We can switch off the gearbox. Some people call it PHY. We do have HBM in the ASIC. Just next to the ASIC, we do have HBM. If it's not needed, if customer wants the shallow buffer, they can shut down the HBM external buffer. Rearranging the ports, right? We could save a lot of power. MACsec disable, we have seen it. So far we have seen the power optimization techniques at within the system, right? In a given network, what are the techniques we have it, right? So let's take the top topology. Here it's very clear, right? If you can intelligently consolidate the traffic into the top link, you have the opportunity to switch off the below links, right? That would save some power. So in this topology, we have a flow from R3 to R5, R3 to R4 and R5. One thing we can do, we can move this flow into here so that you can switch off the power of the link. But the trade-off here is it has additional hop count. So whenever you implement all this power optimization technique, you need to really see what's the downside. Is there a trade-off or is there a degradation in the performance? So you need to analyze and then apply that. So in this, if one hop count is not a matter for customer, we can move this traffic towards R4 and then switch it off. The other opportunity, you can move this flow to this side, R3 to R5. Here we have an opportunity to switch off this link as well as this link, and sometimes if there is no traffic through R4, we could even power off the whole node. That's a huge power savings in this topology. Right? This is the network wide. Not done yet. We have done a simulation with this kind of topology by moving certain flows from certain links, right? Let's say we have moved around 15%, by moving 15% load from certain links, we could able to save 40% of power in the whole network. So we need more innovations to move the load without affecting the performance. So what are those innovations, right? It's all aligning in the traffic engineering concepts. Okay, I would add more here. This involves TED, right? We do have a lot of RFCs talking about power-aware traffic engineering. The IGP and BGP protocol takes latency, bandwidth, throughput, the hop count. These are the metrics or attributes for them to decide a path. Going forward, we are going to take the power consumption of a link as well as the cost of the power involved in this path. We are going to take additional power related parameters into the traffic engineering protocol and then decide the path, right? So that way we can find an power efficient path for all the traffic, and then we could save a lot of power in the network. So that needs protocol level modifications. What's ahead, right, in this topic? So we have seen power optimization at system level and network level and protocol level. The good thing is we have more suggestions and ideas along with that. We do have RFCs and IETF drafts which talks about routing using the power metrics, and then we have to use AML algorithms to forecast the traffic and predict the ideal time, off-peak time, and then dynamically switch off the components or the whole network, depends on the topology. Dynamically we can switch off the systems. All these things we cannot do it. We have to give all the historical data and the ability to power off all the components and the node to AML agent. Since SoNIC is very open and AML friendly, we could run an agent in the SoNIC to take care of all these things. That's the second idea. The last one I would say is like SDN. So we could create a power policies and then apply it in either in SDN controller, or you can put it in the control plane of the system itself. Since SoNIC has SDN ready infrastructure, it's a wonderful OS to apply all these ideas to make it a reality. One thing I want to say, as we all know, right, SoNIC routing stack, it's not on par with other proprietary NOS, right? This is a good opportunity to add more value into the SoNIC routing stack, so that we can compete really with the proprietary NOS, right? So we can do this quickly in SoNIC with the community help to add more value. Okay, so one company or one person cannot do this actually. We cannot do it alone. We need to do it together, and by doing collaboration. Collaboration is the key. we need to have a cross-industry collaboration, especially vendors, customers, researchers, policymakers, right? We need to collaborate with all these people and then see how quickly we can implement all these ideas in SoNIC ecosystem. Why policymakers? Certain Europe countries, they are giving tax credit if you are a green networking company, right? So by quickly implementing this and deploying it in our network, we can showcase that to government and get tax credits. That's the benefit for customers. It's not only reducing the OPEX and power bill, but also they will get tax credits. And we need standards like which highlights the power efficiency as the key metric. When we buy the fan or household things, we see 3 stars, 5 stars, right? But do we have such standards in our networking system? We don't have, unfortunately. We do have some standards for PSUs, the power supply units, gold and titanium standards for PSUs. But we don't have any standard for vendor system, networking system. So we have to think of something in the standards line so that we can ask, is it a 5-star rated, titanium rated networking gear, or is it a gold rated networking gear with respect to power consumption? The final point is there are a lot of ideas in the IETF, RFC and many places, but proprietary NOS, right, they cannot take everything and do it quickly. But we do have a community to do them, to observe them and do it quickly and add value to our SoNIC systems, right? That's about my topic. Let's reduce the power consumption wherever is possible in our system. That will reduce the energy bill, and also it will save our the one and only planet. Thanks so much for this opportunity. Yeah, let me know if any questions. Shoot it, please. Thank you.
We have to save the power not just in our equipment and also in our day-to-day life, so to make our planet green. So I have one question. I think in the hardware equipments, when we are not using that particular component, then we can switch off and then saves the power. That's one way of looking at it in saving the power. But the other, I think, ideal innovation should come from based on the usage of that component. For example, some of the components can be operated in a low power mode, and then dynamically it has to derive based on the traffic patterns. It can go to the normal mode or in the low power mode. And I have seen in the hardware components we used to integrate, for example, the hash tables and the TCAMs in the hardware. They can operate in the low power mode. So those are, I think, the ideal candidates for the huge power savings in both in the ASIC area. So and can you throw some light in that segment? Was there some innovation that is happening across the industry? And yeah, and we can talk more on that.
It's a good question. Already we talked. There is a MACsec on and off, right? It's actually a hardware block in the system. If your customer don't need a MACsec, you can disable it. In a closed environment where it's going to talk, all of them are their own company devices where security is not a matter, you can switch off it, right? And it depends on the use case wise, right? You cannot do disable the security in open enterprise or WAN use cases, right? So we do have technologies and ideas to switch off the unused components, and whenever the traffic comes, we can switch it on actually. Yeah, we do have a lot of technologies.
Yeah,
almost all the vendors have those things.
Yeah, basically it should be based on the dynamic pattern of the traffic rather than completely switching off and then switching on the component.
Agree. There are things actually, yeah. Dynamically it can enable and disable the components based on the traffic.
Yeah. Thank you.
I'm trying to check in one of the slides you said, ports need to, if we can move the ports, that helps, right?
Yeah.
Is there anything built in or you're expecting rewiring?
Rewiring, I meant the rewiring.
It's not between moving ports between parallel pipelines in an ASIC or moving things, none of that.
It's a rewiring. Some customers, right? So usually enterprise, they don't have the IT team, right? If in case they have one port connected on the top, one port connected to the bottom, if you could identify like there are multiple ASICs are there, if you move this connection to the top port, we have the opportunity to disable
that. Makes sense. Actually, there is some discussion that was happening with Surendra at Broadcom on can we really move the ports between the parallel pipelines. Within the ASICs, usually you have 2, 4, or 6 parallel pipelines, and sometimes you can't do the rewiring. Is there a way quickly we could put a mux in
It's
between?
about the external ports, like
internally has a lot of value, looks like, right? So and that's because you are saying you're a product guy now. It's important to go back, tell your engineering to see if they could. It's a little harder, but if they can somehow design.
So whatever I have seen, that's why whenever someone says new system, I always open and see it. The ASICs have hundreds of SerDes connections. All will group as a port group. 8 SerDes will go to one port. These are all fixed in the system. So I'm not sure a dynamic way to move those connections within the system.
There are multiple pipelines to take care of all of them, right? There could be, there's a penalty you pay, but that's the ROI discussion we need to have. But I've also seen some innovation, don't want to mention the company, but on increasing the port speeds and decreasing the port speeds to save the power, just like the traffic.
So we do have a system, like he said, right? Something called low power mode. It's the configurations. If you enable that configurations, we cannot use ZR optics. That takes more power. We cannot use MACsec, right? And even though if it's a 800 gig box, if customer is only looking for 400 gig box, we can enable the low power mode, so that will only give 400 gig capacity. So there are things already.
The dynamic ways of looking at it, based on the dynamic parameters and traffic, then if you can operate your components, I think that's going to give us the very much power savings.
True. That is also there, actually.
Yeah.
Okay. Cool. Do we have any more questions? If not,
okay. Thank you so much.
Thanks, Andre.